Hello, I will be discussing LeetCode question 94, which is binary tree in order traversal. I will not describe it in as much excruciating detail as I did the pre-order. I'll try to link that video in the description. For now, a quick summary is when we are calling functions, we have a call stack, and when we are using recursion, we are exploiting the structure of the call stack, and call stacks have return pointers. Now, the actual data structure stack in a Java or C++, for example, you can only store one value, and it will get very complicated if you store anything outside of the tree node. You can do that, but there is an easier way, and it is a tricky way, but once you see it, it gets easier. So instead of a call stack, what we will have is a return stack. Now, this change in perspective is the entire difference, okay? Now, think about it. Whenever you're executing a call, you enter the function. Now, at this point, you execute this line and you leave the function. So the function has two parts. This is one part, and then after you come back, you print yourself and then you go to another function, but you don't really have to come back. There's nothing to do. So you can think of it as the second part of the function, okay? So we leave the function twice, but we only come back once. Now let me point that out. We leave our function twice, but we only return once. That's the return pointer. Okay, so the way we are going to program this is we are going to execute this part, and then we are going to put this on our return stack. Okay, so I would assume that you know how to do an in-order traversal. Okay, so I will continue with, I'm sorry, yeah, this is an in-order. Yeah, we are doing in order. So we will have a stack and a pointer called current call. So if you are pointing to this, so it in my idea, it means you are calling this on calling the function on whatever node it is, okay? And then this is called the return stack. Return stack. I'm sorry, I think I got cut off. So the return stack means you are going to come back and print your self and your and then make a call on your right child and do whatever. Yeah. So the function will start with one being assigned, the root being assigned to the current call. And what happens when you call? You come into the function, you don't do anything, you make a call and put yourself on a stack so that you can come back. That's what exactly what we're going to do. We aren't going to do anything. We're going to put ourselves on a stack. What does it mean to be on the stack? It means we need to, number one, print call right child. That's what it means to be on the stack. Now, but before we go to the stack, we have to make a call to the left child, right? So we are gonna give the left child of 1 to this pointer. So we have 2 over here. Now, again, what does it mean to make a call? It means to put yourself on the stack and call your left child. What is 2's left child? 4. Okay. What does it mean to make a call? These are getting too big. So we put the 4 over there, and then we are going to call the left child of 4, which happens to be null. Oh, we fell off a tree. Whoops. We fell off a tree. Now, what happens when we fall off a tree? We check, do we have any functions to return to? Yes, there are things on our return pointer. I'm going to make a new pointer called resume. Resume will get stuff for me from the stack. It will get the 4. Okay. So resume has four. What does it mean? What does it mean to resume an execution of this function? It means to print self and then to make another call, but this time to the right child. So that's exactly what we're going to do. So this is our very first print, four. Okay, we printed, fine. Now we're going to make a call. What does it mean to make a call in our scenario? We are making a call to the right child, which is also a null. We assign it here, null. And then we get rid of this garbage collector, eats that. So now we fell off a tree again. We fell off the right child, but it doesn't matter. We fell off a tree. What happens when we fall off a tree? We check our stack, we pop the stack, and we resume execution. Okay, so what does it mean to resume execution? It means to print yourself, call your right child, right? So let's print ourselves. So there is two printed. And what's the right child of 2? That's 5. So let's make a call to the 5. So I put it here. It means I'm calling 5. Okay. Now let's call 5. How do we call 5? We put 5 on the stack. I don't want the big 5. I'm just copying it small. We put 5 on the stack, and we have to put the left child of the 5. We have to call that. Okay. So we are calling 6. Okay. What does it mean to call 6? It means to put 6 on the stack. Oops, wrong tool. It means to put 6 on the stack and call its left child. What's the left child of 6? It is null, right? There's nothing. Whoops, we fell off a tree. What do we do when we fall off a tree? We check to see if we have to call anything else. Okay, we have to resume execution for 6 now. What does it mean to resume execution? Print and call right child. So let us print 6. I just printed 6. Let's call the right child of 6, which is another null. Okay, so I'm gonna call none. Whoops, I fell off the tree. This time on the right hand side. Doesn't matter where I fell off from. I have to resume execution if I have any functions to return to. I resume execution for 5. Okay, what does it mean to resume execution? Print self, call right. Print self. So here is 5. Whoops, wrong color. My battery is low. I hope I can finish recording this. Anyways, so that's 5, and I'm resuming execution. I'm gonna make a call to 7 and vanish because I am done with calling and there's nothing to do. So I'm making a call to 7. What does it mean to make a call? It means to copy myself to the stack, and before I go, give me the left child. Left child of the 7 is null. Okay, we fell off a stack. What does it do? What do we do when we fall off a stack? We get our, whoops, I only got 7 sword. So I get the thing popped off from the stack and print itself and call the right child. So I print 7. What's the right child of 7? Another null. So here you go, null. Whoops, we fell off a tree. What do we do when we fall off a tree? We continue. We check if we have anything to return to. Yes, we do. We have the function to return to. Okay, so what do we I'm so sorry. I think I have already done this. I forgot to pop off two. I'm very tired, so forgive me for that. The two was already popped off. I did not trace it right. So that was a mistake. So let's pop that off. Popping that off will give me 1. I'm gonna, because I've printed everything, right? You see, I've printed 4, 2, 6, 5, 7. So I'm gonna pop off the 1 now. So I did pop off the 1. After popping off, I resume execution. I have to print the 1. Here, I printed the 1, and then I call the right child of the 1. Right child of the 1 is 3, so I assign that to here, 3. Now my stack is empty, but I still have something pointed to. I still have to call this. What does it mean to call? To call means copy yourself over. Oops, I could not get that. I don't want the equal sign. Copy yourself over to the stack and give me your left child. What is the left child of 3? Left child of 3 is null because it does not have any children over there. Okay, I think I fell off a stack again. Put that on resume. And what does it mean to resume? Resume means print yourself. I printed myself and then call my right child. What is the right child of 3? Right child of 3 is 8. I'm going to make a call to it. There, I made a call to it. That garbage collector eats that. Now, okay, I'm making a call. What does it mean to make a call? In this scenario, to make a call means put yourself on the stack and give me your left child. Left child is 9. We are almost done. We are making another call. What does it mean to make a call? Put yourself on the stack, give me your left child. Left child is null. So we fell off a tree. What do we do when we fall off a tree? We resume execution on anything left over. 9 is left over. What does it mean to resume execution? It means to print and call the right child. So I printed, let me call the right child of 9, null. Okay, I called on null. What does it mean? So I just fell off a tree. What happens when I fall off a tree? I resume execution. I bring the 8. What does it mean to resume execution? It means to print and call the right child. Let me print 8, call the right child of 8, null. Okay, so I'm calling the right child of 8, null. Okay, that null means I fell off a tree. Okay, what do we do when we fall off a tree? We check our stack. Okay, stack is empty. So we are done. So when the current falls off a tree and there's nothing to return to, that's our end condition, okay? And if you can see, we printed everything in order nicely. So I'm just going to go through this for a sanity check. So so this is what left root right. So left left root left root right. Did I make a mistake? I'm just going to check the LeetCode answer. No, my thought process was correct. I'm just being silly. So this is correct. This is accurate. This worked. Now I'm gonna share my code with you, and the code will implement this exact same process. Um, Here it is. This just implements the same idea. I'm just gonna show you my variables. So here is a list of integers that I'm gonna return. And here is a stack. I'm calling it literally return stack because it means to me I'm gonna return, print myself, call my right child. That's all I'm gonna do, what this means. Now, if there is no tree, we return something blank. This is a blank list. We return a blank list. It doesn't make sense, but it is there. Now, here's where the fun begins. This variable, current call, this means I am calling, okay? I'm calling the function on something. I'm calling it on the root value, okay. Now here is my while loop, and as you can see, we continue the while loop as long as I have not fallen off the tree and this is not null, okay? So in either of these cases, so this is an or, that means I will run this as long as the thing is not empty, the return stack is not empty, and I have not fallen off a tree. When both is true, then I don't continue anymore. Okay, now let's try to go fall off a tree now, okay? So the first thing to do was to call the call the left child, okay? That's what we're gonna do. If the current call is, so I'm calling something, I'm not calling on null, right? I push myself on the return stack because I want to remember I have to finish this, okay? So I push myself on the return stack and now change the current call variable to the current call dot left. The left could be an actual left child or a null, but if it's an actual left child, I continue this while loop over and over until I fall off the tree. And definitely at this point in the code, I fell off a tree, and there are some some functions in the return stack to return to print myself and to call on the right child. Okay. Now I am making a new variable called resume that pops the return stack, so it gets the first thing off of the stack, and then now I'm printing. This is my printing phase. Actually, let me comment that. I'm printing now. In this loop, I have simply called the left child. I have not printed. When I am back, when I'm popped from the stack, it means I'm back. I can continue execution, okay? I get that result node, that's the tree node. I get its value, put it in the answer list. That's my printing. And then I call. What does it mean to call again? Remember, if I assign this to the current call variable, we interpret that as calling. Okay, call uh, right child recursively, and this one was call left child recursively. Did I spell that right? I hope I did. No, I don't think I did. Recursive. Yeah. Okay. And then this is actually all of it. But again, when I saw this code for the first time in somebody else's explanation, it did not make sense to me at all. That's why I made this video in hopes that it will be a better explanation. Now I will submit this to show you to that this runs. And this is, where is it? Oops. So again, the recursive solution also bits 100%, so it's nothing special. But this is an iterative solution. This gives you a deeper insight into how trees and stacks work, and function returns, and whatchamacallit, recursion works, okay? Thank you for your time. I hope I made this a little more easier for you. Good luck with whatever you're doing. And if you have any questions, please let me know in the comments. Thank you.